Well, let's get ready for our second speaker tonight. You might be familiar with their work. It is one of the big networking crates that we have in our ecosystem. So let me introduce you to Periwink. Here you are, and let me get your slides as well so that you can kickstart it off. Thank you so much for being here, Periwink.
Yeah, sure. My pleasure. So this is Periwink on Discord, and I'm going to talk about Lightyear and how to do multiplayer games with Lightyear. So a little bit about me. I've been involved in Bevy since 2023. I was mostly interested in the ECS originally, and then shifted towards mostly working on the networking side of things. I'm French. I live in New York. I work as a software engineer in a trading company. And I'm a cat dad for a cat called Ollie. This is actually my profile picture on Discord. And I've had actually like at least 5 different people ask me if this was some kind of spider monster, but it's just my cat in reverse. So yeah, nothing to worry about here. So what is Lightyear? So it's trying to be a comprehensive networking library for Bevy that can basically sync data between multiple peers, sync their Bevy timelines as well, exchange messages between those peers, handles input replication. So when you're pressing some buttons, send those inputs from the client to the server. And it can do so by defining your own inputs, but it's also compatible with Leafwing or Bevy Enhanced Input, which is like the latest input library for Bevy. It supports 2 types of replication, which are basically the 2 big paradigms of networking. So one is state replication, where you're directly replicating the state of your world, like you're serializing your entities and resources and sending that to the remote peer, or deterministic replication, where you're just sending the inputs, like which buttons you're pressing, and the remote peer that receives those inputs can reconstruct the state of the world perfectly if the game is deterministic. And it can even do a mix of both, where, for example, the game is deterministic, but when a new client connects, you start by replicating the state of the world, and then you continue by using determinism. And it also has a lot of advanced features that are needed for fast-paced games. So prediction, visibility. So visibility is like sending data only to a subset of clients, delta compression, etc. And I'm going to show and talk about these later. So what is the architecture? I guess the key insights is that each peer, so peer is basically like a client or a computer connected to the network, is an entity in Bevy. And this is really powerful because it allows for a flexible topology. You can have multiple clients, multiple entities inside your app. You could have multiple servers. It can support both a client server or like a peer-to-peer architecture. And then once you have this entity, you can add extra components to tell Lightyear how this peer behaves with the rest of the network. So the main component is the link, which represents basically a link between 2 different computers on the network. And this is what's used to send and receive raw bytes. And there's extra metadata components that can be added. So you can tell, what is the local IP address of the peer, what is the remote address of the peer that you're connected to. There's the same with IDs. So Lightyear assigns like a unique ID to each peer connected on the network. There's also the role. So you can have, you can be a client, a server, a client of a server. So yeah, the name is a bit confusing, but it's basically just the client that is controlled by a given server, and even a host client. So that's when a client acts as both a server and a client in the same app. There are some components that track the status of a given entity, so of a given client or server, like are we connected? Is the server started or stopped? You can also add components to define like how the bytes are going to be sent across the network. So we're using UDP, WebSocket, WebTransport. And yeah, I think that the Bevy ECS is pretty powerful because it allows you to be very flexible in the capabilities that you add to each of these peers, using ECS and components. So one of the big things that Lightyear handles for you is syncing the timeline between the local computer and the remote computer. Because in multiplayer games, there's always multiple timelines involved. And there's basically four big ones. So the local timeline, it's what Lightyear uses to track time in general. And basically, it follows the time resource of Bevy. So there's only one per app, and we increment by one tick every time the fixed update schedule runs. So generally in networking, you use tick to keep track of times, and games usually run at like 64 ticks per second. Then there's a remote timeline. So it's basically our best estimate of the time of the remote computer that we're connected with. And Lightyear estimates this by sending ping and pong packets like all the time. In these packets, each peer writes like their current local time, and so you use this with an averaging algorithm to estimate like the time of the remote timeline. There's the interpolation timeline. So basically, if you simply received a remote packet and use that to display and use that to update your world, your world would be updated in a very not smooth manner because you receive the packets not exactly every frame. You receive them like every 100 milliseconds. Some of the packets might be out of order. So what you need to do generally is keep a buffer of those packets and interpolate between the two consecutive updates that you received from the remote. And to do this, you need to be a bit in the past because you have to wait for the buffer to fill up. So that's what's shown here. The interpolation timeline is slightly in the past compared to the remote. And then the final timeline that's being used, and that's basically equivalent to the local timeline. That's the one that drives the Bevy time resource, is the input timeline. And this one is in the future compared to the remote because Lightyear wants to do prediction. So when you press on a button, we don't want to wait for a round trip where the input press is given to the server updates the world and sends some update back. And then once we receive the updates, we move our character. Now, what we want to do is that the moment you press on the button, your character moves on the screen. And then we send the input to the server. And when the server receives it, it applies that input. And for that to happen, you need to be ahead of the server. So when you press a button on tick 5, you send that to the server, and that message has to arrive on the server before the server does tick 5. So the input timeline has to be ahead by basically the round trip time, like half of the round trip time between you and the server. So that's why there's like all these different timelines, and Lightyear helps keep those in sync. And then there's extra components that basically let you add extra capabilities to each of the peers connected on the network. So there's, for example, message sending. So you can add message sender or message receiver for a given struct to be able to serialize and deserialize the raw bytes that you receive into actual structs that you can use. There's also replication. So replication receiver, replication sender. That's basically like sending the states of the ECS, so the components and the entities of your world, to the remote world. And then there's some extra components that can be added to enable prediction or interpolation. So on the right, I put a little code snippet of what it would look like to add a new peer to your app. So you can add each of these components. So you can specify that this is a client. There's the link that's used to send and receive the raw bytes. You have to specify the address, both the local IP address and the remote IP address. And then you can add replication, prediction, etc. And on the snippets at the bottom, that's how you would replicate an entity to some remote peers. So for example, this is an entity spawned on a server, and you can say, I want to replicate this to other clients, and you can specify to which clients you want to replicate. So this would be replicated to all the clients that are connected to the server, and then you can specify which clients are going to do prediction, which ones are going to do interpolation. And now I'm going to basically show you like how it works by walking through a couple of examples, to show you like how it looks like. Let me just slow down the video a little bit. So in here you have two clients connected to a server, and this client is the one moving first, and I'm showing all the timelines at the same time. So you're pressing a button, and this is the square on the predicted timeline. So that's why it appears first, and it seems to move first compared to the other ones. Whenever you press the button, some messages are being sent to the server that receives the button presses, and the server updates the state of the world using those messages. But you can see that the client has already updated the state of the world. That's prediction. Like you update it as soon as the button is getting pressed. And then the server sends the state of the world back to both clients. So you can see on the client 2 here in the past that red square is the replication timeline. So it's the updates that we receive from the server. And it's not very smooth. So as you can see, it's what I was saying earlier. Like we receive those updates every 100 milliseconds, sometimes out of order. And so that's why what we need to do is here that last square is the interpolation timeline. It's slightly in the past compared to the updates that we receive, but it interpolates smoothly between 2 consecutive updates so that on your screen, everything appears to be smooth. So yeah, that's what Lightyear enables you to do in a relatively easy manner. So now I'm gonna walk through some of the other advanced features that I was talking about earlier. So one of them is visibility. So you can say that an entity is replicated to all the other clients of your network, but then sometimes it's useful to be able to say like replicate to everyone except those 2 players, or and this is what visibility allows you to do. So there's 2 ways of doing this. One is you have this replication state component, and you can say gain visibility, lose visibility on your given like peer entity. And the other one is rooms. So rooms is kind of a persistent way of managing visibility where you can create a room entity. You add some entities to it, and you add some senders, like some peers to it. And the entity will be replicated to all the senders with which it shares a room. So that makes it like fairly easy to handle this kind of stuff. And this is what it would look like. So basically in this example, you have 2 players connected to the server, and those 2 players are in the same room. So they're always going to be visible to each other. But these little green dots are each like a unique entity. And these are added to the room only when they're close to a given player. So then that's what it looks like. When the player is moving, those entities get spawned and despawned very quickly. So each of them, when they get spawned and despawned, it's the server sending messages like, please despawn those green dots, spawn those green dots, and it's happening like all the time. So another thing that Lightyear enables you to do is client-to-server replication. And the reason why this is simple is because everything is based on components. So there's no logic that's really gated to the server or to the client. Like any peer that has replication sender added to it can have the capability of sending replication updates to the remote, which I think is pretty powerful. So this is what it looks like basically to enable client-to-server replication. So here I'm querying for an entity that has a client component, and I'm adding replication sender to it with like some extra parameters. Yeah, and that's it. But then what happens when both the client and the server have this replication sender component? Because then they would each send updates to each other, and it would get confusing. So Lightyear under the hood tracks which peer has authority over a given entity. So there's always only one peer in the network that is allowed to simulate and send replication updates to the remote, and that's called having authority. And when you don't have authority, you cannot send these replication updates. So this is like pretty powerful. And I'm gonna give you 2 examples of how it can be used. So one of them is, for example, you want to replicate your cursor, like that you move on the client directly to the server. And this can be done simply by client-to-server replication. So here I'm moving the cursor on the client. The state of the circle is getting sent to the server, and the server then replicates it back to the other clients. So this is what it could look like. But another thing that's pretty useful is that you can swap authority between different entities. So in this example, that circle here is an entity, and it's being replicated by all of the different peers on the network. So each of the peers have replication sender, and each of these are trying to replicate it to the other peers of the network. However, there's only one entity, one peer that has the authority over these components, and the authority is tracked by the color of the circle. So right now, when it's close to the green player has authority. And so you can see that it has authority because the green circle moves smoothly here because it's being simulated inside this app. And it's not smooth in the other two apps because it's just receiving replication packets. So it's receiving them every 100 milliseconds. That's why it appears not very smooth. And then at this point, when it's far, the server gets authority over entity, and the server now has a job of simulating it. So for these other peers, they're just receiving simulation packets. And then again, it moves towards the authority is given to that other client. And this can be useful, for example, in peer-to-peer games or in like more massive games where a client will be simulating the environment around them. Like if you have a huge world to render, it can be good to distribute the load of simulating the world between multiple clients. Another thing that lightyear enables to do is compatibility with Avian. So Avian is, I think, one of the preferred physics library with Rapier for Bevy. And it's kind of tricky to combine networking and physics because there's a lot of things to be aware of. There's a lot of system ordering between prediction, interpolation, and physics that need to be tuned carefully. So lightyear Avian is a plugin that allows you to do all of this fairly seamlessly. It syncs the necessary components and resources. And there's some extra things that it provides for you. For example, lag compensation, which is something that's needed for FPS games. So Avian has this like spatial query system param that can be used to cast array. And you can use the lag compensation spatial query, which has exactly the same API, but will deal with the timelines, apply like some interpolation delay to do lag compensation. So this is what it looks like to run Avian and lightyear together. So this is like in a 3D environment this time, and yeah, everything gets replicated. I just wanted to show this example because there's also like this debug UI that I added that shows you the number of messages that are being sent, the amount of data that is being transmitted, the number of rollbacks that are happening during prediction. So it can be useful to debug if there's like any problem in your app. And lastly, what are some of the next steps? So one of the big next steps that I'm planning to do is to replace the replication logic. So basically everything that's handled by replication receiver and replication sender to use Bevy Replicon. So that's another networking library that's very popular and yeah, very impressive. And originally, lightyear had a lot more features, especially around visibility, around delta compression. You were able to replicate only one component, things like that. And yeah, Bevy Replicon has been adding all of these in the last year or two. So now, yeah, they're pretty similar in features. So I think, yeah, it's the right move to move lightyear to use this library. And another thing I want to do is that most of the examples in the lightyear repo are mostly for the client-server architecture. But as I mentioned, normally there's no reason for peer-to-peer examples not to work with the lightyear's architecture. So I kind of want to try adding examples using peer-to-peer. And yeah, that's it. So quick overview of how lightyear works and what it allows you to do.
Wow, thank you so much. This was a lot, super interesting, and it's impressive how much lightyear supports in terms of features. That's crazy. We got a load of questions, so let's start from the top. How does lightyear perform with thousands of dynamic units on screen? Is the bandwidth usage optimized for this?
Yeah, I think it's fairly optimized. I haven't really tested with thousands of units, but I know that Replicon can handle this kind of loads, and I'm going to switch to Replicon pretty soon, so it should be okay. But yeah, lightyear does have some features that allow you to be careful around bandwidth. So like one of them is delta compression. I didn't really talk too much about it, but what it means is basically that if instead of replicating and serializing the states of your components, you're instead serializing the diff between your components and the version that you sent previously. So you're only sending a diff, which is a shorter amount of data. And another thing that can be used is you can send a maximum bandwidth that is available, for example, like 1 megabyte per second. And there's going to be like a priority scheme where you don't serialize the whole state of the world, but only a subset. and the entities that have higher priority will be sent more frequently, and the ones with less priority, for example, the ones that are far away, will get sent less frequently. So yeah, this can also be used to.
That's cool. All right. Next one. Are you aware of commercial games released using Lightyear?
I'm not aware of any. I think there are some that are using Lightyear, but maybe were not released. I think I've added them to the repo in the README. There's also an example, I think, in the Bevy Jam number 5, I released like a multiplayer game using Lightyear that worked pretty well, just to show like that it can work in a real environment.
Nice.
Yeah. Otherwise, there's no commercial game.
Does it work on WebAssembly, by the way?
Yeah, it works on web as well.
Nice. Okay. Do you compress data send? I guess you already answered that. Delta compression, right?
Yeah, so delta compression is like compressing against the previous state, but otherwise, normally you could also compress the stream of data by applying like ZSD compression, like some of the compression algorithms. This is not something that I do right now, but yeah, I kind of want to support it.
Do you think that's going to make a huge dent?
I think it's pretty important, yeah, because bandwidth is probably your biggest cost for multiplayer game. Compared to like CPU usage, bandwidth can be like a massive cost on games. So that's probably the most important thing to optimize for.
Yeah. Next one is, are you using Lightyear for a game project yourself? I mean, probably aside from the Jam game a few years ago.
Not really. I mean, the reason I started Lightyear was actually because I wanted to re-implement those kind of IO games myself, like Agar IO, like massive games where you can join without any login. And I couldn't find any way to do this in Bevy. So that's kind of what started this project. But now I kind of got sidetracked, and I'm working more on Lightyear than the game itself. So
classic.
Yeah, that's something that I want to work on.
I mean, that's how Bevy started, right? I think we're in good company there. All right. With clients optimistically predicting the timeline, are conflicts possible where two clients optimistically take action which conflict? If so, how do you handle this?
Yeah, so that's the classic problem of prediction. Basically, that you're on your local client, you're predicting something, for example, that you were able to move, but the server knows that you were stunned, for example, by another weapon, and so you were not able to move. When that happens, you have something called a rollback. So basically, on your local client, whenever the server tells you you were wrong in what you were predicting, we roll back the state of the world and repredict like all the frames between the remote timeline and the current timeline. And usually what I try to do is to smooth the rollback. So instead of like snapping back the state of the world to the correction, I do this smoothly over several frames so that it's not too jarring. And which I think is the standard thing to do.
Yeah, makes sense. Which begs the question, like everything is totally dependent on the input being properly hooked in, right? And you mentioned supporting Leafwing and the enhanced input. Is it like, it's possible, I guess, to extend it just with your own whatever input library you want to use, right? Or make it completely custom?
Yeah, so yeah, you can use Leafwing, Bevy enhanced input, or send your own structs, like define your own struct or enum for your input.
Okay.
That. But yeah, I would recommend using Bevy enhanced input. I think it's pretty good.
Makes sense. Nice. The authority system for replication reminds me of Rust's ownership and move concepts. Are they related concepts in the code?
Not really. I think like authority is basically just like a Boolean flag right now that tells you like, do I have authority or not? And you can send in a message to say like, give authority or request authority from another peer in the network. So that's, it's implemented like rather simply. There's no like link to ownership.
Yeah. Oh, this one's interesting. Do you think Lightyear will ever become upstreamed in the distant future?
I'm not sure. I don't really think so. I mean, at least it's not really a priority for Bevy. there's a lot of other things to work on, and something like networking. Like basically the problem is that as soon as something gets upstreamed, it gets harder to make progress on it because there's a lot more eyes on it. The bar for a PR getting merged is very high, and yeah, sometimes it's actually the right move for a library to not be upstream and to remain a third party for a long time so that you can make changes to it. And I'm also not really sure that Lightyear's current API is the one that I want to stick with. There might be like breaking changes in the future. So
rewrite coming up.
I mean, there's already like the Bevy Replicon like the merge with Replicon, which is gonna change like quite a lot of things, I think. So
when do you expect that to land?
not immediately, but maybe like in like 3-4 months, something like that.
Nice. Yeah, I mean, it really is a great testament of the modularity of plugins in Bevy, right? That we probably end up having like all these different backend implementations for what you mentioned, like WebSocket and UDP or whatever, which is already what Replicon builds on top of, right? And then you building on top of Replicon once this merge has been done. It's a really nice way to really pick and choose for the user.
Yeah, I agree. I mean, honestly, I think that sometimes, when you touch Bevy too much, as soon as you write Rust code that is not Bevy, you're suddenly lost because, in Bevy, all the lifetimes are kind of handled for you. You can query anything. Like everything just works magically. And it kind of like, ruins like normal Rust for you.
Yeah. I mean, perfect segue from the first presentation that we've seen. Like,
yeah, exactly.
I totally agree. Like, wait, I don't get my dependencies automatically injected. How do people do that? All right. How do you handle times potentially jumping backwards? I guess because you said you smooth over, right? So it could also be that it would require you to jump back when you keep ping-ponging.
Yeah, that's a good question. So for the timeline sync, what happens is that the time of the server is like the golden time that every peer network tries to stay close to. And it stay close to it by speeding up or slowing down your local time. So if you notice that you're like far ahead, you're gonna like start slowing down, and the speed is set to like 97% or something, or like slow. But sometimes there's like a big move, or you're suddenly like change connections, or like you switch to Wi-Fi, and you need to actually do a big time jump. And in this case, there's like an event getting emitted that changes your tick. For example, you can go backwards in time, and it's gonna look pretty jarring on your screen, but otherwise, there's not much that you can do, I think.
Yeah, I mean, I'm just curious about all these edge cases that are potentially possible when you do like the timeline is based on this ping-ponging. I mean, that could also mean that it takes a while until it's really like settling on something that's probably reliable, right? So I guess there's some warm-up going on before this is even used.
Yeah, like we wait for at least like 7 or 8 like round trips before using the value.
Yeah. Which goes hand in hand with the next question. How does it handle unstable network conditions, such as high packet loss?
It handled it pretty well. So actually all the examples, like in the link that I was showing earlier, there's here like a settings.conditioner. And the conditioner is basically to apply conditions on the link. So such as like packet loss, like a random reorderings of packets, things like that, latency. So usually when I test with a pretty like maybe 10% packet loss, 100 milliseconds of latency, things like that. And because all the packets are being buffered and you interpolate only between the received packets, like things would still look smooth even like in bad conditions. And you should always test networking in pretty bad conditions because it's pretty easy to get things working with like 10 milliseconds latency, no packet loss, and then have it completely change if you add a bit of latency.
Yeah, that's a good point. I mean, it's good to be able to support that out of the box, right? And basically just by default have it like go almost worst case scenario. If you get it to work properly, then should be pretty safe.
Yeah.
What about like disconnects and stuff? Is that also would that also be automatically handled and reconnect?
So you can disconnect and reconnect, but you can do it manually. There's no like automatic handling for it. There's there's nothing like we save your state or things like that. I think it could be, you know, like a third-party plugin that can like handle this maybe, but yeah, there's nothing like that added currently.
So the user would have to also implement themselves to have some sort of stable ID that that would actually identify this is actually the same person or the same client reconnecting again.
Yeah, correct. Yeah.
Okay.
I mean, Lightyear provides like a stable ID, but Lightyear already provides some stable ID, or like you need to provide a stable ID sometimes for like Lightyear to work properly. But yeah, you will need to handle extra stuff like how do we restore the state for that given things like that.
Yeah. All right. Can a client become host and clients migrate?
Yeah. So basically, the role thing is completely dynamic since it's based on components. So you could have, you know, a client be a normal client, and then you add the server component on it, and it becomes both the server of the game for clients connected to it, and one of the clients connected to that server. So that's something that's possible. So yeah, that client basically becomes like a host client. So that's the component I added here, which is just a marker component. Is every time you see a client that's both a client and a server, then we add this. I think it's convenient, but it can be tricky to get right because there's a lot of edge cases in your queries to handle. So generally, another approach would be to have two apps running on the same computer and to use like a channel to send messages like instantly between them with no latency. And in that case, like, you know, the two apps are independent, so there's no extra complexity. But yeah, it adds more like CPU processing.
Interesting. So does it come with any sort of implementation for, I guess, IPC, or what are you suggesting here to do this communication?
Just like channels. So like one of the transports, like at the bottom, there's like web transport Steam, but you can also just use like Rust channels, like crossbeam channels to send data.
Yeah, but that wouldn't work across processes, right? Or how do you want to do that?
Sorry, yeah, two apps in the same process, but like different.
Okay. Interesting. Okay, we are almost at the end. Is there also a Rapier support? Is there a Rapier support library? Because I guess you mentioned you have a explicit support for Avian. How does it look for Rapier?
Yeah, there's no support for Rapier, mostly because I've never used it, and yeah, I'm not familiar with it. Also because it's easier to work with Avian because it's very tightly coupled with the ECS. Like everything is a plugin. You can order your systems against like Avian systems. I think Rapier doesn't work like that. Like it's not that closely integrated with Bevy, so it can be harder to order like prediction interpolation with like Rapier's physics.
Yeah, I guess it's sort of like it's basically just bridging between like this non-ECS world and making those things available in the ECS, right? So,
yeah. I mean, it might be possible, but I just haven't. Yeah, I haven't looked into it.
But I guess you would be open for someone contributing it if it would come up.
Oh yeah, sure.
Nice. Okay, I think the last question you basically answered, like, does Lightyear require a dedicated server? I guess no. You said you could have a host client or whatever you called it, right?
Yeah, exactly. Yeah.
Yeah, and even dynamically change that. So that's pretty cool.
Yeah.
All right. Cool. Well, Periwink, thanks again. I mean, first of all, for this presentation, but obviously also for the huge effort on maintaining this huge library. And hopefully you will eventually get to the point that you can make use of it for this game project that you always wanted to do with it.
Yeah.